Have you ever written a use effect hook that fetches data from the server and then you had to pull your hair out? You had to manage all the complex state, make sure that the fetch goes through, that it doesn't re-trigger while the component re-renders for some unknown reasons. Then you have to manage your use effect dependency array, then you forget to add something, or you add something and then it infinitely fetches from the server and then you want to cry in the corner. Well then, this is the video for you, because today we'll be talking about React router loaders, and this is meant to cover everything. How they work, when they trigger, when they revalidate, why you should use them, how you should use them, how you can cache stuff in them, everything. So it's going to cover all of the scenarios you need, and after this you'll hopefully be aware of what they are and you'll be able to use them effectively. Alright, so without further ado, let's get started. So, the first question that we want to answer is, what are loaders? So, let's imagine you have some sort of a server, and then you have your client application. So let's call this the client, and then let's draw another circle here. You have your server here, and at the moment, we are talking about classic loaders with the Remix server-side rendering. I'll cover single-page applications later on with client loaders, but these are the normal loaders that execute on the server. So whenever you land on your client website, so let's say you're building some sort of a movie website and you land on it, what's gonna happen is the server is gonna execute the loaders for that page. So what that means is the client is gonna send a request. So I'm gonna call this request to the server, and then the server is gonna say, okay, I'm gonna send this to Remix, and I'm gonna call the loader associated with the route we're on. And because Remix executes loaders in parallel, if you have multiple, what's gonna happen is it's gonna send multiple requests at the same time. And then these loaders are gonna fetch or do whatever they need. So for example, this loader calls a database, and then the database responds to this loader. So let's change the color a bit. And then this one sends a request to a third-party API. So we're gonna say third-party API, and then that responds to the request as well. And both of these loaders are gonna respond from here. And when they do respond, the server is gonna send those responses back to the client. So that's how it works currently. And this is what happens to the loaders. So what's important here is that the client makes a request to the server. The server in parallel executes your loader 1 and your loader 2, or however many loaders you have on the route, and each loader corresponds to a URL segment, and all of these loaders execute their own things and they send back responses to the server, and then the server responds back to the client. And if you navigate to a new page, the same cycle happens all over again. So this is basically what loaders are. They're something like your API endpoints, but instead of calling them directly from your client, so in a side of a use effect, they're already living on the server and they're gonna execute for your URL before it's loaded. So what this means is by the time the client renders your React component, the data is already there and you don't have to worry about it. And whenever you change the URL, it's gonna fetch the new data and load it in, and then by the time those React components are loaded in, the data is already there. So this completely eliminates the need for any third-party libraries on the client, which is kind of a hard thing to give up on, like using 10-stack query, which is one of the best packages out there for this kind of thing. But just the sheer power of loaders makes them kind of redundant, because you don't need any sort of fetching hooks on the client. It can already be done on the server. And this is the current approach that Remix takes with loaders. But there's a new thing coming to React Router 7, and that's single fetch. So single fetch is going to change how all of this works, and it's going to change it in the following way. So instead of the server sending requests to the loaders in parallel and then responding in parallel, what's going to happen is there's going to be additional complexity here. So what is going to happen is all of these things are going to stay the same. So the server is still going to send requests to the loaders in parallel, but there's gonna be another layer here, and that layer is gonna be first of all, when the request reaches the server, is going to call on the server context. And this is maybe far in the future. I'm not sure when the server context API is gonna land in Remix, but the server context is meant to load up your data before it even calls the loaders. So this would mean something like your currently logged in user, something shared like project config and stuff like that. And I'm gonna delete these arrows, and the request is gonna go to these. And once the server context finishes processing, it's gonna call another layer called middleware. And as you can guess, middleware is gonna do something before and after the request is done. And then after the middleware is done, it's gonna call each one of your loaders again, and they're gonna fire in parallel. Loader 1 is gonna call the DB, loader 2 is gonna call the third-party API, and then they're gonna respond back to the middleware. The middleware is gonna go back to the server, so like this, and then the server is not gonna respond in parallel like this. It's gonna wait for all of these requests to finish, and then it's gonna send everything back in a single fetch, so in a single payload. And that is the difference between how it works at the moment and how it's gonna work in the future. The decision behind this is because this is how it currently works without the server context and the middleware. When you make a document request to the server, and the document request, if you don't know, is the first initial request you make when you land on a page. So basically when you open up a new page, this is what happens. And then the following requests are not document requests, but rather data requests. And the reason for single fetch is because the behavior is different between document requests and requests that happen after that. The idea is to make the behavior identical on every request, and that way the amount of bugs is lowered, because you could end up with race conditions because you use different approaches, and this way it's all a single approach, so the code is easier, it's easier to maintain, but that doesn't matter much for you because you're the end user and you just want it to work, but that's the idea behind it. And the cool thing is, because this would execute in a single fetch and it will return a single response, you can add server context and middleware in between before you answer. Alright, that's super fine and dandy, but what can you actually return from loaders? So there are multiple things you can return, and I'm gonna switch to a new screen and start over again so we can go through what you can do with loaders and what you can return. Alright, so let's look at the flow now and see what we can do and what we can return. Let's imagine you're either navigating to a new page in your existing application, or you're trying to load the initial page for the first time. So you make a request to the server. So you land on a new page, the request is made to the server. The server itself is gonna say, hey, call the loader, and the loader is gonna do the following. So it needs to return either a response or throw something. So there are three scenarios here. The first one is if you respond with a response. So if you respond with a response, it's gonna go back to the server, and then the server is gonna send back the data to the component, and the component is gonna render. And that's the happy path. You've landed in the component, it renders, and that's it. The second scenario is the loader throws a response. So when a loader throws a response, the server is gonna respond, but it's not gonna render the component, it's gonna go into the error boundary. And the error boundary itself will not have the error inside of it, but it will have the thrown response, and that is what used to be called a catch boundary, but it's merged into the error boundary now. So this would be the catch boundary of before, and it would be the error boundary of now. And the third scenario is if you throw an error. So if you throw something like new error not found, it's still gonna end up in the error boundary, but the error boundary is gonna have the error now, so you can use the use error hook and render something differently. So this would be your classical error boundary from Remix version 1. And these are the 3 possible ways that the loader can do something with the data and return it. And now the cool thing is, when you're returning the data from the server, it doesn't have to be resolved right away. So what this means is, if you, for example, return a defer, and I'm gonna make this blue, what is gonna happen is you're gonna initialize the data in the loader itself. So for example, you're gonna make a call to a third-party API, and let's imagine this is really slow. It takes 5 seconds. So let's say we're waiting for the response from the third-party API, and I'm gonna make this a little bit larger. So let's say we're waiting for 5 seconds. We respond right away with the defer. It's gonna go to the client. It's gonna send the data that it already has to the client. And then the client is gonna call suspense because it received a deferred promise from the server. The server is still waiting for the third-party API, and once it responds, this will again go through the server and return the data to the suspense again. So what's gonna happen is, after like 5 seconds, this is gonna return and then render the content that was supposed to be rendered after this is done resolving. So what this means is, instead of waiting for 5 seconds to show the UI, you're gonna show it right away, defer the request, and once the third-party API sends the request back to the loader, it's gonna be piped to the component on the client and then rendered. And this is one of the coolest uses for loaders, because you don't have to wait for the slow stuff to happen. You can render right away and just wait until it's resolved. But this is where single fetch comes in to improve stuff yet again. So single fetch. Before, without single fetch, what would happen here is, let's say you had an object. So I'm gonna just create an object here, and let's say you had a promise and this was something, and you return this to the client. Now the issue with the defer from before is, if this something had nested promises. So for example, let's say nested promise. All right, so if this was the data you were sending back, this wouldn't work with defer, because defer could only defer promises on the backend if it was the first layer of the object. So nested promises wouldn't work. But with single fetch here, they work. So instead of returning defer, you just return the raw object like it is here, and that would go into the suspense boundary. And then if the nested promise was there as well, it wouldn't break, it would still work, and wait for the nested promise to resolve as well. Or what you could do is render a part of the UI and wait for the suspended stuff to resolve before you continue. So for example, you have 2 suspense boundaries and one of them renders the root, so this promise, and the other one renders the nested promise. And that's the cool thing about single fetch, is that it even improves further on this functionality and allows you to be even more flexible on how you render stuff. Alright, now that you understand what the loaders can return, there's another concept you need to understand, and that is, when do loaders refire? So let's go to a new page and let's go over that as well. So there are 5 ways for loaders to refire, and it all starts with the component. So we have our component here, and let's say you already fired the loader, you landed on the page and the component is there, and let's say the URL is user/1. Alright, so the first scenario is you call an action. The component submits to an action, and after the action is done processing, it's going to re-trigger all the loaders. So what's gonna happen is, if you have a loader here, the action is gonna re-trigger it and all the other loaders on the page. So if the user/1 has 2 loaders, the first one is on the user segment and the second one is on the 1 segment, it's gonna refire both the loaders and they're gonna resend the data back to the component. So that is the first case, and we're gonna say action-based re-triggers. Alright, so this is the first scenario. The second scenario is if I do some editing magic and switch back to what we had before, if you use navigate or any other way to navigate to a different page. So let's say component 2, and the URL for this is, for example, user/1/edit. It's going to trigger the loader for the edit segment, but it's not gonna trigger the loader for user/1. So what this means is if you're loading a new path, it's not gonna re-trigger the loaders that were already triggered because it assumes that you don't have any new data in the loaders for the exact same route, but just a segment on top. So it's not gonna refire them. But when they are gonna refire is if you change the dynamic param. So for example, if you navigate from user 1 to user 2, then all of the loaders are gonna re-trigger again. And this is the second scenario, and it's re-trigger on param change. So what this means is whenever you change the parameters in the URL, it's gonna re-trigger. And a very similar example is re-trigger on search param change. And what this means is, let's say you're not navigating from user 1 to user 2, you're navigating from user 1 to user 1, but you add something like query is equal to test. And if you navigate and change the search parameters, even if it is to a same page, it's going to re-trigger every loader. And this is called re-trigger on search param change. So whenever you change the search param, and even if you change the value of the search param, so you instead of qtest, it's qtest1, it's still going to re-trigger all the loaders. And that's the third scenario. The fourth scenario is very simple. So if I do the editing magic again, the component 1 can import and use a special hook called useRevalidator. And if you use the useRevalidator hook to again render the component, it's going to re-trigger the whole flow again. So that's re-trigger on useRevalidator. So that is the fourth scenario. And the fifth scenario is if you use navigation or any other sort of navigation tool to navigate to the same page. So this is maybe unintuitive, but for example, let's say somewhere on the page you somehow change what is supposed to be on the loader, and then you use a navigation to navigate to the same page. And for example, this could be like to show toast message or to do something else. You can navigate to the same page and the loaders are gonna re-trigger. That is the fifth scenario, and we're gonna call it re-trigger on same route navigation. So these are the 5 scenarios that can happen. So re-trigger on param change, re-trigger on search param change, re-trigger on same route navigation, re-trigger on action submission, and re-trigger with useRevalidator. Alright, and now you might be wondering, is there a way for me to stop this? So for example, if I navigate to the same page, I don't want them to trigger. Well, there is. Before each loader is triggered, and if I edit this again, the first thing that happens is the component sends the request. The component is gonna call the shouldRevalidate export that's exported from the route module. And after the shouldRevalidate, if it's a yes, it's gonna re-trigger the loaders. So loaders, and it's gonna then send back the data. If the answer is no, it's not gonna call the loaders. So the shouldRevalidate here is the perfect way for you to stop loaders refiring, but these are meant to be used in very special circumstances, and you shouldn't use these to not re-trigger loaders a lot, because this is meant to be an optimization, and if you use these, this can lead to stale data or data not being up to date or data mismatches, because when you don't re-trigger the loader, you can't be certain that the data is fresh. So you really need to be careful with shouldRevalidate, and this is just an escape hatch that Remix offers, but you shouldn't really rely on this because of the reasons I just mentioned. And that is everything you need to know about shouldRevalidate. So it's an escape hatch. It takes A lot of parameters, you can find the exact docs on the Remix website or the React.router website, depending on when you're watching the video. And that's it. So we just learned how loaders revalidate, how you can stop them from doing that, what they are, and how they work. And now I'm gonna go into some practical examples, and I'm gonna show you all the cool tricks you can do with loaders, how you can cache some data, how you can speed it up, how you can slow it down. I'm not sure if you want to slow it down, but you can. And yes, I'm gonna be using sleep for that. And that's it. Let's jump into that part. Alright, now I've switched over to StackBlitz, and I want to show you some cool little tricks you can do with loaders, how they work in action and not just in theory, how you can do all the stuff I talked about earlier. Alright, so the first thing is, like I said, this is on the server, and the right side is what's rendered in the browser. If I refresh this, actually the first thing we need to do is we're gonna add Remix development tools, and as the person who created them, I have no idea what the latest version is, so I'm gonna check. Alright, I've checked and it's 441, and we're gonna save this, and we're gonna go to our Vite config, and then inside of here we're gonna plop them in. Import Remix dev tools from Remix development tools, and then we're just gonna do Remix dev tools here, and this doesn't work because we haven't installed it, so let's do npm install. Alright, and let's start the dev again. Alright, and now we can see our loaders trigger. So as you can see, route/index just triggered, and as I said, so when the page loads, the loader is called and it returns some data, and then in this component here you can consume that data. And how that would work is, for example, if I return something and then some string here, and then I consume it on the client, so data is equal to useLoader data, and this is imported from Remix.run React. Alright, and then I save this, and then instead of all of this, I'm gonna close this, and then I'm gonna do div, and then I'm gonna close the div, and then I'm gonna do data dot something, and as you can see, we can see some string. Alright, so as I said, the loaders execute on the server, but now if I do something like this, so const sleep is equal to, so milliseconds number, and this returns a new promise, and it's gonna resolve with set timeout of resolve and the milliseconds. Alright, so let's say I sleep here for 3 seconds. So first let's make this loader async. And then what we're gonna do is we're gonna say await sleep 300 milliseconds. As you can see, the loader for the route index now takes 3 seconds to render. And if I refresh this, as you can see, it took 3 seconds to refresh. This means until the loader is done, your UI is not gonna load. And what can this mean? So for example, let's say this was a response from a server, and you want to do something with the response. You would have to wait for 3 seconds every time when the loader triggers. And obviously you don't want to do that. And to make this error on the data go away, we're gonna do a type of loader here. That's how you type the loader. And now the something is a string. Alright, so as I said, loaders trigger, then the UI does. So until the loaders are done, your UI is kind of blocked. So what can you do to avoid this issue? So what you can do is, you can use the defer keyword I was talking about earlier. So you can do defer from node, and we're gonna return the response. So what does this do? At the moment, nothing. As you can see, it still takes 300 milliseconds, 3000 milliseconds in order for the request to go through. And the reason behind that is because we're awaiting the sleep here. So if I remove this, as you can see, okay, so the reason this error happened here is because Remix, when waiting for a response on the server, at least with the non-single fetch implementation, whatever you return that's not of type defer, JSON and stuff like that, or even nested defer promises, what it's gonna do is it's gonna try to pass it into a response object, and the response object takes null, but it doesn't take undefined, and that's why this crashes. So the easy way to fix this is we're gonna say, instead of resolve here like this, we're just gonna do this, and then we're gonna resolve with null. and this works again. And as you can see, the loader again takes 0 milliseconds, and because we're deferring the value here, you can see that the deferred value is detected in route/index, and the key is response. And as you can see, the second log says that the defer value responded after 3000 milliseconds, after 3 seconds. So what this means is, and actually let's return string here. Looking at the right side, you can see the welcome to Remix and some string. So what we can do here is we can use suspense from React, and because it's a promise, we're gonna say the fallback is loading, and we're gonna use the await from remix.run/react, and the resolve is gonna be data.response. And then we're gonna do this, so div. Alright, as you can see, if I refresh the page, it instantly loads and says some string here. That's the value we return here. And then for the response, that's awaited for 3 seconds. If I refresh, it says loading, so it's the suspense. And then after it resolves, we can see what it is. So it's a response. This is of type unknown, that's why it's complaining. But because we return a string here, we already know what it is. So the UI is not blocked. It still waits for 3 seconds, and then it returns it. Alright, so that's how you use defer, and that's how you use a loader. Now, let's say you want to do something different. So let's say you want to fetch from an API, and you have to wait for 3 seconds, because for some reason you need that data later on. So for example, when you get this response, you have to parse it and then do something with it, transform it, or pass it along to your implementation of something in order to get some different data and then send it to the user. And you don't want to call that API all the time. What you can do is you can install a caching library. For example, I'm gonna install LRU cache, and what I'm gonna do is I'm gonna import it, and I'm gonna say LRU cache from LRU cache. I'm gonna create a new instance here, so cache is equal to LRU cache, and you gotta do new here. And now there's a lot of config you can do here. We can say, for example, max is 500, and I don't know, size is 500, whatever. I mean, this is not the point of this video, so we're gonna gloss over the LRU cache part. But let's say you got the response and it took 3 seconds. So we're gonna await this, and it took 3 seconds. So, and we're gonna instantiate this outside. So what you can do is say the response after it's retrieved, you're gonna do cache set response, and then we're gonna do whatever the response returns. Okay, so I'm gonna do as any here because that's not the point of this exercise. So the first time the loader takes 3 seconds. The second time when we get here, what we want to do is we're gonna say if cache get response, so the same key as below, we're gonna return the defer right away with something being some string before and the response. And the response is gonna be actually a cache get response. And we save this. Alright, so the first time it took 3000 milliseconds. The second time, because we stored it in cache, it took again almost instantly to respond, and you can see it's the some string before. So another way you can actually speed up the loader is by setting stuff in cache, and then if the cache is there, instead of fetching this again, you just return early or do some calculations and then return. I mean, the exact details are up to you, but this is one trick to do it. Another trick you can use to speed up your loaders is actually use a different kind of cache, and that is browser cache, or rather cache headers. And what are cache headers? So cache headers are special headers that tell the browser to store the response in a cache. And what this means is, depending on the cache header, you can either store the cache in browsers, so locally in users' browsers, or you can store them in a CDN. And that depends on the cache header. And how do you do that? You just do here in the headers, you're gonna do this, and then you're gonna do cache control, and then you can do something like private. So this would store the response in the user's browser, and that's a private cache, or it depends a bit on where you host it and how you configure your server. By default, in local development, this would store it in the browser. And if I remove all of this, alright, so 3 seconds, And I need to set the max age to, I don't know, 500. And we're gonna do JSON here, which we don't have, JSON. And as you can see, the route has been cached for 8 minutes and 20 seconds. Caveat I remembered here is that this might not be cached because of stack blitz. It's a little bit hard to play around with cache when it's emulated, but generally if you set it with the cache control header, this is cached either privately in the browser or on a CDN on a server. And the best part about a cache on the CDN is that it's instantly fetched when needed, and that means for every user. So whenever a user enters your website and the request is cached, that means when a second user enters your website, they're gonna get it instantly because the other user already triggered it and stored it in cache, so the second user already has the cached values. Alright, so that's another option you have. Let's say you don't want to use any of these, and let's say this is maybe the root loader and you want it to trigger only once and you don't want it to trigger on changes to the children. So what we can do here is if you go to the root here and export a loader, so export const loader, and I'm gonna return null here. Alright, so this triggered, and then export const shouldRevalidate. And this needs to be a function that returns a boolean. I'm gonna say false, and I'm gonna save these. So if I go back here, as I already told you, when you navigate to the same site, when you set the search params, when you change the parameters, loaders retrigger. So for example here, if I use search params, and this is imported from Remix.run/React, search params, set search params. Let's say there's a button here and click me, and what the button does is on click I'm gonna set the search params. I'm gonna do params.set, name is test, and I need to actually return the search params, so params and return params. So if I do this, you can see that the URL ends with webcontainer.io. So if I click this, and I need to save this first, sorry, and then if I click this, you can see the loader took 3 seconds, but the root loader that was triggered didn't do anything. And if I click this again, it again sets the search params. The loader triggers for 3 seconds, but the root loader doesn't because we set it to shouldRevalidate to false. So that's how you use shouldRevalidate to not trigger loaders. Like I said previously, it's an escape hatch, so you shouldn't use it by default, but it's a convenient way to disallow re-renders. And the last convenient way to actually cache your loader data is by actually using client loaders, but I'm not gonna go into that now. I'm gonna do a video on client loaders as well. I'm gonna go over how that caching works, but for now you can know that there's a convenient library called Remix Client Cache, and it uses tail while revalidate strategy by default, and it's a single line of code change, so you can use that as well. But these are kind of all the tricks you can use to speed up your loaders. And the last thing I want to show you is, if you remember, I said that these have to be on the top of the loader when using the fur. So if I go to read-config, if I do unstable single fetch to true, and if I go here and I remove JSON and then I delete this and save it, if I refresh this, you can see it still works. And if I do something like this, so nested response, and then on the client I do data.nested.response and save it, as you can see on the right, even though it's nested inside of an object, it still works. So a cool thing you can do is you can do something like this. So response 2 is sleep for 5000 milliseconds, so 5 seconds. And then if I copy this and I do loading 2 and response, so if I refresh this, you can see this one is loading, it's done. And then I replace this with response 2 and save it. So loading, done, loading 2, and the server timed out. I guess 5000 is too much. I'll do 4000 and save it. Let's try this. So loading, done, loading, done. And as you can see, you can basically stack them and run them in parallel as well, so you're not limited there as well. And that's another way to actually speed up your development. So this comes with single fetch, but single fetch is unstable at the moment, at least at the time of making of this video. So maybe this is not the way to do it at the moment, but in the future this will be the default anyway, so it's gonna be a great convenience because you don't even have to use defer here or anything like that. You can just return the loader like this and you're done. And that's pretty much it. We've covered everything there is to know about loaders, how they work, when they retrigger, how you can optimize them and speed them up, how you can use caching with them, what the strategies are, and you're ready to start your project. If you have any questions about loaders, feel free to ask them in the comments. If you like this kind of video, please let me know. I'm willing to make videos on all the other things in Remix, so actions, client loaders, client actions, some strategies you can use with them, some cool little tricks like the one with the caching and the loaders, and everything in between. If you like this video, consider subscribing to the channel. It's a huge help. Help me share the video with others. And that's it for today. Thank you for watching and see you in the next one. Bye!